everyone, hope all is well today. My name is Lamotte. We'll discuss the computation of a sample mean and sample standard deviation for the values that we find in question 5. So here we have a numerical variable, which is the annual number of deaths caused by tornadoes in the United States. For example, the first value is 53, so in that particular year there are 53 deaths. And then what we'll do is we'll compute the mean of these 10 values. So here we have a sample size of 10. For these 10 numerical values, we'll compute the mean and the sample standard deviation. Okay, and so we'll start with a computation of two sums. So here I'm going to do the sum of the n values, and then I'll also do the sum of the squares. And so we have 53 plus 39 and so on right up to 90. As I add them up, I end up with 630. And then I do the same with the squares. So 53 squared, 39 squared, and so on, right up to 90 squared. And I end up with sum of the squares of 50,030. Okay, so with the total, which is 630, we can get the sample mean. So this will denote as x bar. This is the sum of the observations divided by the total number of observations that we have, so the sample size. And so this is 630 in this case divided by 10, which is 63. Okay, so I'll keep this information on the side. So I have n equal to 10, and then I have x bar, which is equal to 63, and then eventually I'll also need the sum of the squares, which is equal to 50,030. Okay, so 50,030. Alright, so now our next step is to compute the sample standard deviation. So I'll start actually by using a computational formula, which is a shortcut formula if you want, in some sense, which will allow us to compute the standard deviation in some efficient way by using a handheld calculator. Okay, and so here what I'll do is I'll denote it S. This is our standard deviation, and this will be computed in the following way. And so it's a square root, and then denominator inside of the square root we have n minus 1, and then in the numerator we have x sum of these squares minus, we're going to take away a square. So it's the square of what? It's the square of the total, and this square will have been divided by the number of observations that we have. So in our example, in the denominator inside of the square root, here we have 10 minus 1, which is actually 9. We have the sum of the squares, which is 50,030. From that, we take away a squared, which has been divided by 10. And the square is the square of the total. So in our case, it's 63. Okay, and then as we do this computation, this will give us a sample standard deviation of, and so this will imply that the sample standard deviation is equal to 33, and then what I'll do is I'll just round it to 2 decimal places. So the sample standard deviation is 33.90. Okay, so this is an efficient way to compute the sample standard deviation when we're given a sample of values. Okay, so what I'll do is I'll just erase my work of the sample standard deviation here. I'll write down the standard deviation on the side, so just to keep note of it. So S here is equal to 33.90, and then what I'll do is show you an alternative computation based actually on the definition of the sample variance. And so when we think in terms of variability, we want to know, well, how far are the values away from the center, where we measure the center by using the mean. And so what I'll do is I'll construct a little table. So here we have the values of x, which are 53, 39, and so on, right up to 90. And then each one of these values I'll compare to the mean. So here, for example, I do 53 minus 63, and so I end up with minus 10. For 39, I do 39 minus 63, I end up with minus 24, and so on, right up to 90. 90 minus 63 is 27. And then we'll be interested of the square deviations. So this will be a measure of distance. So how far is 53 from the mean in terms of square deviations? So I square minus 10, so I get 100. I square minus 24, I get 576, and I do this for each value. 27 squared is 729. Okay, and then what we'll want to do is get the total. So we'll compute the total of the square deviations. In this case, this is going to be 10,340. 10,340. And so now I'm ready to compute the variance. So the variance is the sum of the square deviations away from the mean, and then what I'll do is I'll compute the average of these square deviations approximately by dividing by n minus 1. It's divided by n minus 1 for some technical reasons. Okay, so I get 10,340, and then I divide by 10 minus 1, and then this gives us 1,148.889, and then to compute the sample standard deviation, I take the square root of s squared, so I take the square root of 1,148.889. I end up, if I round to 2 decimal places, I end up with 33.90. And so we see that this is actually the same value that we had computed earlier by using our shortcut formula. Okay, and so there are different ways to compute the sample standard deviation, either using our computational or shortcut formula, or by reverting back to the definition of the sample variance. Alright, so that's it for the computation of the mean and the variance. Thank you.